So then I did want to take a moment because I wanted to talk about how we describe linear motion. And it kind of gets broken into two pieces. When we talk about something moving just left or right or up or down or forward and backward, um, typically I'm going to take it from the assumption we're talking right and left. We want to know when is it moving right, when is it moving left, when is it stopped, and we want to know when does it speed up, when does it slow down. So this is easiest to discuss with an example. So if it wants to go forward to my example, come on, there we go. So we want to describe a particle's motion whose displacement is given by our cubic function t cubed minus 6t squared plus 9t. So I always start with dealing with the whole idea of left and right and stopped. So to do that, I first need the velocity, which is the derivative of displacement. So that's 3t squared minus 12t plus 9. I have an unfair advantage that I know that I'm going to need to be solving this at some point, so I'm going to go ahead and factor this. So I can pull a 3 out of everything. And this is going to be 3 times t minus 3 times t minus 1. Again, I have the unfair advantage. I know what I'm going to be doing with this. You could do this at a later step without any issues. So it's easiest to talk about where's this stopped. So it is stopped when v of t equals 0. In other words, when 3 times t minus 3 times t minus 1 equals 0. Well, that's at t equals 3 and t equals 1. So this is a good thing for me to know, is that, hey, this is stopped at those times. But then I also need to talk about when is it moving right and when is it moving left. So it's moving to the right when v of t is greater than 0, and it's moving left when v of t is less than 0. Well, the easiest way to talk about this is actually to make what is called a sign chart. So I'm going to draw a number line. On this number line, I'm going to put my domain. Well, since t is representing time, t doesn't go negative. So t is starting at 0, and then I'm not given a stopping time. And then I'm going to put when is it stopped on my number line. So I'm going to put 1 and 3. Make sure you're putting them in the correct spots on the number line. And then I make a little note to myself that this is for velocity. And all I really want to know is where is my velocity positive, where is it negative? I put 1 and 3 on there because velocity is 0 at those times. And I don't want to get those accidentally plugged in then. So I then pick a number between 0 and 1, like 1/2, and I plug that in for t in my velocity equation. Well, if t is 1/2, I'm going to have positive 3 times a negative number times a negative number, which will be positive. So this means that we're moving right because the velocity is positive there. I don't care what the exact value is. I just care that it's positive. I then pick a number between 1 and 3, say 2. Plug that in for t in the velocity equation. Well, I get 3 times negative 1 times positive 1, but what I care about is that's a negative number. And so my particle is moving left there. And then if I pick something bigger than 3, like 5, well, I have 3 times positive 2 times positive 4. Well, what I care about is that's a positive number, and the particle is moving right at that time. So in words, what I would say is the particle moves right for the times from 0 up till 1, stops at t equals 1, moves left for t from 1 to 3, stops at t equals 3, and then moves right for t's greater than 3. And this is half of my description. And that I now know, okay, at any given time, what direction is this particle moving? But then I need to worry about speed up and slow down, which means I need to know where's my velocity positive and negative. Oh, what do you know? I already know where is my velocity positive and negative. But I also need to know where's my acceleration positive and negative. So for that, I need an equation for acceleration, which is the derivative of velocity. And that would be 6t minus 12, or if I factor that, pull a 6 out. And I'm actually going to kind of take the same approach as I did with velocity, because I want to know where's the acceleration 0, where's the acceleration positive, where's the acceleration negative. Well, acceleration is 0 when 6 times t minus 2 is 0, meaning at t equals 2. So again, I'm going to make a sign chart. Time starts at 0 because we don't have negative times. The only place my acceleration is equal to 0 is at 2. So from 0 to 2, I'll take a value of 1, plug that in for t, and I have a negative acceleration. Pick something bigger than 2, like 3, and I have a positive acceleration. If I combine my two sign charts into one chart, I have a 1, a 2, and a 3. Here's my velocity, here's my acceleration. From 0 to 1, velocity was positive. From 1 all the way to 3, velocity was negative, and then after 3, velocity was positive. From 0 to all the way to 2, acceleration is negative. From 2, anything bigger than 2, acceleration was positive. And now I can see from 0 to 1, velocity and acceleration have opposite signs, so the particle slows down. For t's from 0 to 1. Then from 1 to 2, velocity and acceleration have the same side, so the particle speeds up for times from 1 to 2. From 2 to 3, opposite signs, so it slows down. And then after 3, the particle is speeding up. And here is the other half of my description. So I know from 0 to 1, my particle is moving to the right but slowing down. It stops at 1. From 1 to 2, it's moving left and speeding up. And then at 2, it's still moving left, but it's starting to slow down. Stops at 3, and then starts moving to the right and speeding up. And you'll see that's a better description in terms of, rather than talking about positive, negative velocities, we're talking about what direction is it moving in, is it speeding up or slowing down.